Assalamualaikum warahmatullahi wabarakatuh. We from Group 9 will be presenting the topic Haloalkanes. First and foremost, I would like to introduce ourselves. My name is Muhammad Faris Ridwan bin Muhammad Fadil, matrix number 9211650. Next is Nurqistina binti Muhammad Izani, matrix number 9211627. Next, Nazatul Shimma binti Isah, matrix number 9211637. Moving on, Chapter 7, Haloalkanes. What is haloalkanes, you may ask? Haloalkanes are a group of chemical compounds derived from alkanes containing one or more halogens atom as their functional group. For example, CFC, chlorofluorocarbon, CHCl3, chloroform, and CCl4, tetrachloride. Task A. Synthesis and reactions of organic compounds. Question 9. Complete the diagram by drawing the structural formula of A until G. Give the IUPAC name of compound A until G respectively. The diagram given, as you can see, it starts off from 1/3 butyl 1-cyclohexene. For A, from given 1/3 butyl 1-cyclohexane, it reacts with HBr and CH3COOH to form compound A. The double bond here will burst and the hydrogen and bromine will enter it. It will follow anti-Markovnikov rule. Anti-Markovnikov rule states that hydrogen will attach to the carbon that has less hydrogen number attached to it. That is why the name is 1-bromo 2/3 butyl cyclohexane. For B, 1-bromo 2/3 butyl cyclohexane reacts with potassium hydroxide aqueous at reflux to form compound B. The, the hydroxide ion will replace bromine. So the structure will be like this, as shown. How to name it? OH will be the parent, so the name is 2/3 butyl cyclohexanol. For C, 1-bromo 2/3 butyl cyclohexane reacts with excess ammonia to form primary amine. The primary amine NH2 will replace Br. NH2 will have high priority, so we'll start with NH2, and the name is 2/3 butyl cyclohexanamine. For D, 1-bromo 2/3 butyl cyclohexane reacts with potassium cyanide KCN with presence of reflux to form nitrate compound, which is compound D. The CN, the CN form the CN from KCN will replace Br. So we will start with CN. The name is 1/3 butyl 2-cyanocyclohexane. For E, 1/3 butyl 2-cyanocyclohexane reacts with lithium aluminium hydride LiAlH with ether and H3O+ to produce primary amine. The primary amine will be the parent and the rest will be the substituent. The name is 2/3 butyl cyclohexyl methanamide. For F, 1/3 butyl 2-cyanocyclohexane reacts with H2SO4 with heat to produce carboxylic acid. The carboxylic acid will not include in the longest chain, which is cyclohexane. That is why we name it 2/3 butyl cyclohexane carboxylic acid. And lastly, for G, 1/3 butyl 1-cyclohexene reacts with Br2CCl4 in dark, it will produce vicinal dihalides. The double bond will burst and the bromine will be added in the bond. That is Br at carbon 1 and 2. The name will be 1,2-dibromo 1/3 butyl cyclohexane.
Next, suggest a reagent and condition to produce compound A from suitable alkane. Give the structure of alkane used. The reagent is bromine gas and the condition is UV light. Haloalkanes can be produced from alkanes through free radical substitution reaction, which is UV light. So, compound A can be produced from 3rd butyl cyclohexane plus bromine gas through free radical substitution reaction. The major product formed from this reaction is the most stable haloalkanes. Next, show the reaction mechanism if compound A undergoes SN1 reaction to produce compound B. What is SN1? SN1 is unimolecular nucleophilic substitution reaction. So, step 1 is formation of carbocation. Carbon is delta positive and bromine is delta negative. So in this reaction, the bond between C and Br will break uh, because Br is more electronegative. It will attract all the bonding electron toward itself and it will leave the carbon as carbocation. To break the bond between Br and C, we need to do it slowly, so the red reaction is slow. Step 2 is nucleophilic attack on carbocation. The carbocation from step 1 will react with nucleophile, which is OH negative, this one, OH negative. The nucleophile is rich with electron, will be attacked by carbocation. Yes. So product will be formed where nucleophile will be attached to the carbocation. So we will have new product where OH negative, no, only OH. OH attached to the carbocation.
Next, moving on to task B. The plant that we have chosen for task B is banana. The functional group is hydrocarbon. One of the Quranic verses that are related to banana is Surah Al-Waqi'ah verse 29.
وطلح منضود.
And banana trees layered with fruit. Okay, so in banana, there is a lot of eating. So, why is it called eating? This is because there are two C and there is double bond. So, double bond is in. So, that is why this structure is called eating. Okay, moving on to synthesis of eating. From ethanol, which is C2H5OH gas, um, reverse equation with catalyst to produce ethene, C2H4 gas, and water, which is H2O gas. The catalyst being used here is H2SO4, which is acid sulfuric. Composition of one serving or one medium ripe banana. There are 110 calories with 0 gram fat, 1 gram protein, 28 gram carbohydrate, 15 gram sugar, 3 gram fiber, and 450 milligram potassium. Bananas release gas called ethene and make other fruit ripen. Total aromatic concentration was higher in naturally ripened bananas compared to ethylene-treated bananas. Ethene causes ripening or softening of fruit by the breakdown of cell walls, conversion of starches to sugars, and the disappearance of acids. Next, benefits of banana. Banana is rich in nutrients, contain a fair amount of fiber and several antioxidants. Antioxidants may reduce the risk of many diseases including heart disease and certain cancers. Banana also may improve blood sugar levels, which is rich in soluble fiber that dissolves in liquid to form a gel and support digestive health. Next, banana is a good source of potassium. A diet high potassium can lower blood pressure in people with elevated level and benefits heart health and improve kidney health. That's all from us. Thank you.